So today we're looking at page 232 in the workbook and reminding ourselves a bit about box and whisker graphs, trying to remember from our last statistics topic what exactly these can represent. So for a few reminders for us, a few key points: the minimum, the lower quartile, the median, the max, and the upper quartile. And each graph has these key points. So if we remember, the minimum, this is the lowest possible value that you have in the entire set of data that you're looking at. And the lower quartile is the mark where 25% of the data falls below that. And then the area between the lower quartile and the median is another 25% of the data. So 25% of the population's results fall below the lower quartile, and then another 25% fall between the lower quartile and the median, which means that below the median is 50% of the population. So the median is actually the middle value, and we can see that above the median is the other 50% of the population. And with symmetry, between the median and the upper quartile, there is another 25% of the population. And then from the upper quartile to the max, your final 25% of the population. So it breaks it into nice little sections there, little quarters. And it's easy to compare the results of two different populations when you have a box and whisker graph. And if you remember from our last topic, part of that comparison, the way that we talk about it, is whether or not the median falls inside or outside the box. So in this case, the median of both the males and the females is outside the box of the other population. So in this case, we could say that there is a statistical difference in the throwing distance of the men and the women in this competition. So because the male median is outside the female's box, we can conclude there is a difference statistically. So in this case, we can conclude that men actually do throw farther than females. And sometimes, don't forget, we represent things as little x's here as an outlier. Sometimes it doesn't make sense to include all the data. So with that in mind, let's take a look at a box and whisker graph and see what we can figure out. So on to the next page, looking at question 53. This is one of the homework problems. They've given us all the data points, and they've also given us the statistics. So we don't have to worry about doing too many of the calculations here. But if we take a look at this data, let's figure out what it represents. So we're looking at the amount of pay that male and female employees are given at a company. So females have a minimum of 185, lower quartile of 265, median of 370, upper quartile of 275, and max of 695. So the first thing that we're asked to do is use these parameters, draw two box and whisker graphs, and on the axis below, and represent each of the take-home pay. What conclusions can you draw about the sex? And use the raw data to check if you have any outliers. So that's the first thing that we should do, is check for any outliers. So in this case, if we take a look at the male population, we're seeing lots of numbers that are above 200 and below 700. We do see a few in the 600s, so the top range doesn't seem so bad, 690 to 475, not so bad. But the bottom one, here's one that kind of stands out, 191. The next closest minimum value there is 257, so that one might be considered somewhat of an outlier. So we could say the minimum should actually be 257. And for the females, let's look at them as well. See lots of data points that are within 100 and 200, 300. So here's a 500, 695, that's pretty big. What else do we see? The closest thing we see to 695 is actually 595. That's over $100 difference. So that one also might be considered an outlier. And we would call our max then to be 595. So, in this case, let's take a look at plotting this data. And instead of putting it into our calculator to find the little differences between not including these min and max outliers, let's just assume that well, maybe not the best idea to assume that the data has not changed. So, if we take a look again, and we've eliminated our outliers, so we're going to remove the 191 point and the 695 point. You guys might remember how to do this in your calculators, but if we take a look, we can go back to menu, go to stat, backwards into here. You should see this, so you can enter in a list of data. So I've entered in the min under list 1, and I've entered in the women under list 2. So let's go ahead and remove the data point, the 191 data point. There it is. It should be at the top of your list if you enter in all the data, but we'll take him out. And for the women, we're going to eliminate the 695. There that one is. Okay, so let's see how this changes the statistics. So if you have more than one list of data, you can select which one you're looking at if you go to set first. And for the one variable x list, list 1, that means I'm looking at list 1. And that's list 1, that's my min. So this will give me my result for my min. If we scroll down, these are the variables that are important to us. So we now have 257, 419, that's changed. A median of 483, that's also changed. Quartile 3, an upper quartile of 560, also changed. So we need to update this. So it's going to become 419, 483, and we have 560 for my upper quartile, and the max still stays the same. So 560 and 690. Let's look at the women. So exit to get backwards, and now we want to look at the other list, list 2. So I'm going to go into set and choose list 2. Once I've selected list 2, this will give me the results for my females if I again enter variable 1. So now I'm looking at my females without the outlier. So in this case, my min is 185. 262 has changed, so let's go ahead and write in the changes here, 262 and 653. 262, 653, 365, 419.5, and we have that we've changed already, 595. So these are the new results that we can use for this data table. So in the standard, it's really important that you guys are taking the time to look at the data that's being given to you and make sure that you agree with it. So let's go ahead and plot these. Females at 185, starting for the minimum. So hard to be precise on this graph, but we'll be precise as we can. We know that 185 is somewhere between 175 and 200, so we'll go ahead and put in a minimum here. Our lower quartile is going to be at 262, so again that's going to be somewhere right in here. And a median of 370 will be just below the 375 mark. Upper quartile of 425. Well, that's right on the line. Oh, sorry, not 425, it's changed to 419, that's right. So a little bit lower. 419. And a max of 595. Be very close to 600. So we have all of our marks, connecting them in. This becomes our box and whisker graph for the females. And we'll do the min as well. So their minimum is now at 257. So 257 comes right into here. And that looks good. 419. That's almost the same as the upper quartile of the women, so 419 should be about the same. And 483 be somewhere up in here. And 560 somewhere in here. And a max of 690 up near 700. So here's my points. Bottom 25%. Upper quartile mark. And the maximum, and this is for the males. So, starting to compare these data, what conclusions can we draw about the pay of each sex? Well, just looking at the graph, what would you assume? What would you think here? First thing that we can compare is our medians. We see that in this case the median for both of these is outside the box of the other one. So that would indicate that there is a statistical difference. We can conclude. But what can we conclude? We can conclude that the males are actually paid more than the females. So I would say because the median is outside the box for the females, and I guess we should say because the male median is outside the box for the females, there is a difference in pay. Men are paid more. Sad but true in this case. So, what else can we say about this? Let's get into more details. If we look at the bottom part of the question, part B, that they're asking us, the firm claims to pay its female and male employees similarly. So is that true? Looking at the graph, we can see it's not, but how do we comment on this? So comment on the similarities and differences in the pay and make conclusions as to whether the employer pays each sex equally. Well, remember that the box and whisker graphs show us quarters of the population quite well. So if we want to color in, this is 50% of the females. So 50% of them. And those 50% are getting paid less than what? Less than, well, hard to say, but less than at least 75% of the men. Because from here up is 75% of the men. So I guess we can start with the median. Median of men is above the upper quartile of the females. So what does that mean? That means 50% of the men are paid more than 75% of the females. What else do we have? And actually, if we come back and look at this, really, it's not just that the median, so the median is outside the box, but again, sorry, that's 75% of the population. So we can actually say that 75% of the men are paid more than 75% of the female. That's a pretty significant difference. What else could we say? The median value of, what was it for females? q53.365 compared to 483. Well, that's over $100 difference between that. So there is a, what is that? $123 difference in favor of the men. So the middle value of men's pay is $125 more than the middle value of the female's pay. Again, pretty significantly different. So in this case, I would say the firm is lying to say it pays equally. Again, looking at this, we can see 75% of the men's population makes more than 75% of the females. So from here down, that's 75%. And it's actually probably even more than that. But as we see, the box and whisker graph gives us good information. We can compare the means, see that one is significantly lower than the other, and we can look at percentages of the population and see that 75% of the men are actually paid more than 75% of the females. So definitely not a fair situation.